Next is the properties of a vector product. The first property of a vector product is anti-commutative, which means A cross B is equals to minus B cross A. So this is the meaning of anti-commutative. How? Okay. Now, when I say A cross B, that means if you say A cross B, you are rotating the vector from A to B through an angle theta. So this A cross B is equals to magnitude of the first vector, magnitude of the second, and the angle in this case as you rotate the vector in anti-clockwise direction. So this theta here is positive. So just sine theta. Fine. So that is A cross B. So when you rotate A cross B, when you rotate the vector from A to B, you will get a third vector, right, which is perpendicular to the plane containing both A arrow and B arrow. So my A cross B in this case will be pointing out. Fine. Next, if I say B cross A, then if you see B cross A, that means you are rotating the vector from B to A. Let's say you rotate through an angle theta. So again, following the definitions of cross product, I can say this B cross A will be the magnitude of the first vector, magnitude of the second times sine theta. Since you are rotating the vector in clockwise direction, so theta here is negative. So instead of sine theta, I'll write sine minus theta. Or B cross A is equals to, we know sine minus theta is equals to minus sine theta. Okay, sine minus theta is equals to minus sine theta. So taking this minus in front, I'll write B A sine theta. Or B cross A is equals to minus. Now the product BA is the same as AB. Just the product of the magnitude is commutative. Because B and A are magnitude, so they are just like multiplying a number. 2 into 3 is same as 3 into 2 because the result is 6 always. So instead of BA, I'll write AB and then sine theta. Or B cross A is equals to how much? It's equals to minus. Now AB sine theta is equals to what? Is equals to A cross B. So therefore, B cross A is equals to minus A cross B. Or I can say A cross B is equals to minus B cross A. So this is the meaning of anti-commutative. Right? So this is the first property. The second property is vector product is distributive over addition. Mathematically, A cross B inside bracket B plus C is equals to A cross B plus A cross C. So that is the meaning of the distributive law over addition. Third property, vector product of two parallel or anti-parallel vector is always equals to 0. So when I say parallel vector, it means the angle between the two vectors, suppose if this is vector A and this is vector B, they are pointing in the same direction, so the angle between them is 0. And if they are anti-parallel, it means if this is my vector B and that is vector A, so the angle between them is 180 degree. Here the angle is 0 degree. So when the angle is 0 or 180 degree, you will find the vector product is equals to 0. How? Okay, let us prove. We know A cross B is equals to AB sine theta. Now this theta always stands for the angle between A and B. So when they are parallel, theta is how much? 0. So AB sine 0 degree. And you know sine 0 is 0, so 0 into AB will be 0. Again, A cross B is equals to, when they are anti-parallel, what about theta here? Angle theta is equals to sine 180 degree. And you know sine 180 is 0, so 0 into AB will be 0. So that is why the vector product of two parallel or anti-parallel vector is always equals to 0. Property number 4. The magnitude of the vector product of two mutually perpendicular vectors is equals to the product of their magnitudes. How? Okay. So when two vectors are mutually perpendicular, it means this is vector A, this is vector B. The angle between them is 90 degree. So it means theta here is how much? 90 degree. Then what is the magnitude of the vector product? We know the magnitude of the vector product is written as modulus of A cross B, and this is equals to AB sine theta, or AB, but theta in this case is 90, so sine 90 degree, or sine 90 is 1, so 1 times AB will be just AB. So AB means it is the product of the magnitude of the two vectors. Okay, so that is the meaning of this property. Property number 5 is about the vector product of orthogonal unit vectors. So we know, we have learned before, there are 3 unit vectors, I cap, j cap and k cap. These 3 unit vectors, they are pointing along x-axis, y-axis and z-axis, and so they are mutually or orthogonally perpendicular to each other. In other words, I can say the angle between any 2 unit vectors is always equals to 90 degree. Okay, right? So now, the magnitude of the unit vectors, the magnitude of I cap is the same as the magnitude of j cap, is the same as the magnitude of k cap, and it is always equals to 1. Alright? Now, let us see I cross j. I cross j, it means magnitude of I, magnitude of j, sine of the angle between them is sine 90 degree, theta is 90, and n cap, right? Okay, so you know this magnitude is 1, this is 1, sine 90 is 1, so 1 times 1 times 1 is equals to 1, so 1 into n cap will be n cap. Now what is this n cap? It's just like in the case of A cross B is equals to AB sine theta n cap. Now this n cap, if you remember, it is the unit vector perpendicular to both A and B. So then for I cross J, we have n cap. So this n cap, it should be a unit vector perpendicular to both I and J. So that means if this is I, this is J, then what will be the unit vector perpendicular to I and J? Obviously, it will be vector K. So therefore, I can see here that this I cross J is equals to K cap. Similarly, if you take J cross K, you will get I cap. You'll get a vector which is perpendicular to both J cap and K cap. And if you take K cross I, then you will get the third vector, that is J cap. Alright? Now, but if I reverse the direction, like J cross I, if you remember, A cross B is equals to minus B cross A. Okay, so J cross I will be equals to minus I cross J. If I cross J is equals to K cap, then J cross I will be equals to minus K cap. Similarly, if you take K cross J, you'll get minus I cap. If you take I cross K, you will get minus J cap. Okay, So to remember the cross product of these orthogonal vectors, then we use one simple trick here. Like this is a circle, this is my I cap, let's say this is j and this is k cap. So if you rotate the vector in anti-clockwise direction by taking any two adjacent vector, like when you take I cross j, you should get the third vector k cap. When you take j cross k, you should get I. When you take k cross I, you should get j. Okay? But when you reverse the direction, like instead of anti-clockwise, now we rotate in clockwise. This is I, this is j, this is k. Now when you take j cross I, you should get a third vector, but because you are going in clockwise, so it should be negative. Similarly, I cross k, it will be equals to minus j. K cross j, it will be equals to minus I. So these are the two figures which helps you to get the results of the the vector product of the orthogonal vectors. So these are all about the properties of the vector products of two vectors a arrow and b arrow, and as well as the vector products of the orthogonal unit vectors.